Hey, thank you so much for being here. We met just a few minutes ago, and it's exciting. I think one of the things that's amazing, you have truly left a mark on this industry, right? It's a name that comes with such amazing prominence. I think one of the things that's interesting, you've seen this DevOps landscape evolve. You've watched this grow through processes. What are the things that excite you? What are the things that we should be looking forward to in DevOps going forward?
So a little context, the first time I heard the word DevOps, I was working in a financial institution in operations. This is like 2009. And the way it was set up, second floor is for all the operations people, people doing QA and testing, and third floor was for developers. And the developers open tickets for deployments through Jira, and then you get the ticket on the second floor and you do the work, rinse and repeat. And there were people that were there for 20 years, and I swear they had 20 years of 1 year experience. That was the scope of their abilities. And I remember one day I went up to the third floor, and I stayed there. And I'm sitting there, and I taught myself how to do Java because I got started complaining that the logs that they were writing were just like errors that you had to ignore. Who logs errors that you should ignore? So I figured we can fix them, but no one had priority. So I stayed on that third floor, learned Java, and started to do things that sped things up to the point where we weren't getting so many Jira tickets. There was a problem. Hey, Kelsey, you're shortcutting the process. This isn't gonna work. And second, why are you not at your assigned seat? It's on the second floor. I'm like, really? This is the discussion we're having? And they also reminded me that jeans are only things you wear on Friday. And I'm sitting here like, damn, is this the right job for me? And so I remember I started that company as a contractor. Maybe you have the 3 months to perm, and it's around November. And the only person in the office that doesn't have vacation time is me. So everyone else is out on vacation. I'm sitting there doing the deployments. And the way the process worked was there was this SharePoint thing. And in the SharePoint, there's like these steps you follow to a T. Something PCI, something regulation. And you would copy and paste. And the first time I did it, you log into the server, and there's a script you're supposed to copy and just paste the command and run it. And I ran it and it gave me an error. And you're sitting there, it's like, I don't know if these docs are up to date. So what do you do as a good engineer? You run the history command. And it turns out I ain't the only one that's having this problem. And you run ls in that directory, and there's all these scripts like deployment.ksh for those corn shell people out there. And there's another script in there's like, deploy-this one fixes the bug. You should run it only on Fridays, .ksh. I was like, why don't you just delete the other one if this is the one we're supposed to run? And so you run it, and then that one works. And you're deciding, should I update the docs or should I leave it this way? And then I remember replacing that whole process with some automation that just let them open the ticket, and we would pull things from custom fields from Jira, and the deployments would just happen. I'm just by myself. I opened a ticket, it got closed in like 30 seconds. Opened a ticket, it got closed in 30 seconds. Well, the team came back. They're like, Kelsey, what the hell are you doing? People are expecting deployments to get done in 30 seconds. You're not following the process, obviously, and we need to see what you're doing. And there was this huge challenge that I shouldn't be doing this. And I would go on to bring in things like Puppet, do the hard battle to get that into production over a year. And I remember my manager that gave me a hard time about pushing things a little too fast, going to the third floor without permission. He went to a conference, and he came back enlightened. He says, Kelsey, I know what you're doing. I said, what am I doing? He said, you're doing DevOps. I said, what the hell is DevOps? And he had this slide of a person in San Francisco dancing all by themselves. You know the classic DevOps slide. And eventually, everyone starts dancing with the person. Kelsey, you've been the person dancing on the hill. I'm like, what the hell is that? But there is real work to be done. So my thoughts on DevOps is that for a lot of people, I'm gonna be honest, I think they've used DevOps as an excuse to keep doing what they're doing and buy themselves some time. We're on a transformation. We're on a journey. If you've been on a journey for 10 years, you might be lost.
I think I'm gonna have to use that one specifically, so I might steal that from you. It's amazing. Throughout your career, I think one of the things you eloquently said that you would love to be remembered as the person who helped other people find out how to be better than they currently are. I think it's an astronomically noble thing to do. And we look at this and we look at developer experience. How do we build on that concept? How do we look and think about this, how organizations or the industry can actually further this with developer experience and really make people's lives better?
I mean, the truth is developer experience starts before the computer boots up. This idea that we're trying to make software easier to write, why are we writing software in the first place? Joining the team and having to go through the psychology of dealing with a manager that is unclear on what to do. The OKRs, you had to just get them in by Friday. So someone's like, we need at least 4 of these things according to the OKR template. And we got to score them because my director read the OKR book and he wants to copy Google's culture, even though it's like 4 of us. And so that copy and paste culture starts to erode that experience of a developer. You're here to build something. So the experience of like, what do our customers want? And then us getting consensus on what we should build, that's part of the experience too. And for a lot of people, when you have absolute clarity, writing the code ain't the hard part at all. Who cares if I gotta wait for a build if the correct thing is being built? I can do all of that. The problem is we have no idea what we're doing. We're all kind of experimenting like, you know what? Even if that build goes green, it may not work in production. And so I think that developer experience component is a big part of that. So that quote around, I want to be remembered for helping people be better than they were, just taking that whole person to account, you learn to be patient. And when people used to reach out for mentoring, when I was early on in my career, you always want to give them like this sage advice, is like you have all of this stored up wisdom. But the truth is that stuff only worked for me and there was a ton of luck involved. And so you just can't copy and paste that to the next person. It's cool to hear other people's stories, but it's only like an example, right? There's nothing you can do one-to-one. So what I learned to do is something slightly different. My goal now is to just hold up a mirror and convince them to like the person that they see. And I've done that so many times where people shoot me a DM on Twitter and say, hey Kelsey, I'm at some stage of my career and here's what I'm going through and I want some advice from you. And I try to give them some advice that makes them go take action. And there was a time I was in San Francisco walking down one of the streets and someone ran out of this restaurant. I was like, hold on, I don't have no money. And it was a young kid, and he was saying, hey, you may not remember me, Mr. Hightower. He made me feel old. Mr. Hightower, you took a call from a random stranger, and you gave me all of this advice about how to jumpstart my career. I want to let you know that that advice didn't go to waste. And I'm in the tech game now. I actually moved to San Francisco. I'm in the Bay Area. I'm doing all of these things, and I'm more confident than ever. And I saw you walking past while I was eating, and I figured this was my chance to say thank you in person. And so even at that small scale, I felt like I've achieved a lot of those things.
That's amazing. Absolutely amazing. I'm going to get in a little bit of the tech. I think, we look at improving the software delivery lifecycle. Everyone starts with velocity. Let's go fast. But sometimes we forget about the governance, security, the compliance, all those aspects that come with it, the auditability. A lot of those things that they have to do are uncompressible, right? So whether we do them at the far end of it or we do them in the beginning, they have to happen regardless. What do you see industry doing? What do you see companies doing as far as really shifting that workload left, really, moving that security left in the actual entire DevSecOps license?
I want y'all to think about shifting left for a second. What if you went to the airport and the airline chose to shift left, right? You get on the airplane, it's like, hey, yo, you got to fly it. We shifting that left. You're like, nah, I don't know how to fly. It's like, no, we're gonna do self-service airline. No, don't shift left. You only shift left what you don't understand. That's like kicking the can down the road. If you knew you had a security policy, where do you put it? Do you put it in SharePoint and then make it someone else's responsibility, or do you put it in the platform? So think about putting security in the platform. You say, hey, InfoSec has decided that we only want to use these 2 TLS ciphers for encrypting traffic, right? So when a client connects to our web browser, these are the only 2 that are approved. And we go and educate all the developers and we ask them to double check their code and use some AI assistant in their IDE to make sure that they're using, stop! Put in the load balancer. The load balancer is the only thing terminating TLS connections and no one else in the company has to think about it. So all of these things that we're trying to shift left, if you actually know what to do, your goal is to serialize that expertise and put it in the platform. And then everyone that joins the company later, if you've been doing this for a decade, there should be a decade of learning built into the platform. So that way the next developer that comes is just like, oh, I just come and write code. We have so many tools after 10 years of doing this that can generate doing the right thing by default. The problem is everybody's starting over, right? Security's, oh, this is what we're gonna do. They go to a conference, come back, we changing everything. But you ain't finished the last thing. Nah, we got this thing called shift and left. We figure out what it is and we shift it to you. And so you're a developer, you like, y'all done shifted left 500 things. We gotta shift it back, put it in the platform. And when it's in the platform, things become dramatically easier. Like most people, when you think about internet access these days, you buy a phone, you get an eSIM. You ain't even putting SIM cards in your phone anymore. It's just an electronic SIM in your phone, and all the encryption of calls, encryption of data, is just built into the fabric. We don't shift that left. You would laugh at an ISP that told you to become a system administrator so you can get on the internet. That's not what we're doing. So when I think about shift left, these are real concerns. It's great to educate the team about what the requirements are. If you are unsure what to do, bring in people to collaborate. But when you come up with the answer, the best thing you can do not put it in SharePoint. Put it in a platform where it can live. And as things change over time, go and update the platform. So when you say you're a platform engineer, that should be the output of that engineering work.
That's awesome. Thank you. We've talked a lot about the human, right? We've talked about velocity, security, governance, but all around the human, really, the aspect. What's interesting, I think, and we've talked a little bit about it today, is AI. Right? I think there's a lot of things that are happening in the software delivery lifecycle. How do you see AI being leveraged to successfully expand kind of the software delivery lifecycle?
I was given a keynote at a different conference yesterday, and this developer asked, he's like, Kelsey, what do you think about AI disrupting developers and taking our jobs? I was like, man, you was cool 10 years ago when you were out there disrupting all the other industries through software. Now it's coming for you. It's a problem. And then he's like, ethics. When I think about AI today, if you really zoom out and you think about the big picture, computers are super primitive when compared to the human machines that we walk around with. You were born with like this, if you compare it to the state of art for machines today with this supercomputer. You need a couple thousand calories, some water, and you can compute massive amounts of data by just walking around, and the mental models you've been building as a child, all the way to where you are now as an adult. This is the machine that you're walking around with. And when you look at these machines, they're very primitive, right? Look how we have to talk to them. If, else, then do this, run some compiler, double check this thing, go through a whole pipeline. And one of the most powerful programming languages known to humans is spoken language. I can ask you to do something with very little context. You can observe the world around you, you understand the time of day, and you can go execute that request. And they say that the majority of communication is nonverbal, how we move and how we look at each other. So we are an advanced form of communicating with the machines in our lives. And the excitement that I think people get from ChatGPT is that finally, we're getting to the point where we can interact with the computer the way we interact with humans. So naturally, people are excited. It feels like magic, but speaking to another human doesn't feel like magic. So I hope some people go back to appreciate normal human interactions because it's magical compared to the primitive nature of a computer. When I think about ML and AI, especially generative AI, in the concept of like operations and pipelines and infrastructure as code, what I hear is that we're screaming that we've been using terrible APIs all this time. YAML files, XML, JSON, you pick it, doesn't matter what the dialect. Having to try to serialize our thoughts in that manner is too rigid. And so people like this idea of being able to give a prompt, create me a S3 bucket in Amazon. And if I give you that request and you understand who I am, then you know it's me, and you can check my credentials to see if that's an allowed thing. You know the security policy, so it must be in US East, so you don't need that from me. And then the bucket should just appear. And then maybe you can do some sane defaults to make sure that it's secure if that's what we want to have happen. And so when I think about generative AI, people are screaming that, I don't want to make a REST API call. I don't want to write HCL. There has to be a better way to express ourselves. So I think what's going to happen over time, the amount of deployments that cloud providers have seen, the amount of pipelines that people have built in Harness, you should naturally at some point form a model of what's the best and most optimal way of doing something, and then you can reduce the surface of that API down to either some key value pairs if you want to type in a form, or to some language prompt. So to me, this is a natural progression. But here's the last thing I'll say here, though, is we still have to be real with ourselves. These AI things are predicting. These aren't exact. Most of these things aren't scoring 100% in their predictions. They're guessing at what you want based on the input data as applied to the model. That's what they do, they guess. But a lot of things in infrastructure, you want to be precise. You want to literally say US East 1. There's no need to predict when you know. And so I think a lot of people have to back up a little bit and think about a lot of these LLMs as first draft mode. Hey, create an S3 bucket, and it's like, you sure? He's like, yes, that looks about right. And then we can go and troubleshoot and debug. So my thoughts on AI is like, yeah, computers are finally getting to the point of a 5-year-old. It's gonna be amazing.
I love it. I wish I could ask computers to do what my 5-year-old would do, or vice versa. I guess.
They can't.
They cannot. Platform engineering is one of the things that you brought up, and traditionally platform teams have spent their time really integrating all the different necessary pieces, scripts, configurations, plugins, and it's a mess, right? It takes a massive amount of time, massive amount of effort, and even more troubleshooting. Where do you see platform engineering heading? What are the patterns that you see successful organizations actually implementing?
Yeah, you know what? The unfortunate truth is, like, if you've been a platform engineer, you've probably moved companies a couple of times, right? That first week on the job, you'd be like, what the hell is this? You got Oracle and SAP? You've been migrating to Postgres for 7 years? Damn.
7?
Yeah. So you got all this stuff. And you're like, who designed this? It's like, nobody designed it. We just started buying stuff, right? We bought this thing, it required Jira, or we required Oracle, we bought Jira, it required Postgres. And so we just been collecting stuff. And different people have been managing it. And every once in a while we decide we want to consolidate it, and then we want to break it back up. We want to consolidate it, and we want to break it back up. This is the equivalent of trying to design a house with no blueprint. He's like, I have lived in the house before. I've seen a few. I've clicked around on Xylo, but I've never built one. So what we're going to do is going to assemble a team, and we're going to try to do stuff every 2 weeks to see what we get. And we'll ship a roof, and we forgot about the foundation. But look, we can fix it, right? Over time, continuous delivery. We'll keep trying. You keep trying. And a lot of times, people do not actually have done this stuff before. The challenge is that, like, CI/CD is not an evolutionary thing. Could we agree on this? If you've been trying to get a pipeline together for 10 years, there's a problem there, seriously, accountability time. There's no single solution that's gonna work for everybody, but there is a solution for everyone, period. This is not some innovative thing where you need a strategy. No. You need to make decisions. We have software. We've chosen a programming language. We build the software. We package the software. We scan the software. We test the software. And we put the bytes on a server to serve the software. That's all there can be in this form of computing. The problem is people haven't agreed on how to do said thing. And so a lot of times what you see when you see people that don't have pipeline coverage is there's no agreement. One team decides just to do it manually because they feel it's faster. They don't have time to learn the rigid nature of the CI/CD platform. And so I think what we're starting to say here is, like, we got to zoom out and decide that, look, we should take all of this stuff as a platform engineer, and you look at what you have, and you draw a dot, and that's 1.0 of whatever you have. And then going forward, ideally you have a roadmap of the missing pieces. And I think what platform engineering is literally trying to fill in the gaps between what you have and what people want to do. And the dangerous part, though, is when you don't pay attention when the world has changed. There are some people right now still writing bash scripts deploying to Solaris and AIX right now. They have no clue that there's probably a better way of doing this. And a lot of times what I've seen is, like, these large platform teams, they get lost in the thing that they're building themselves. And they say, oh, we want to avoid lock-in. But it's like, dude, now the company's locked into you and your limitations from a platform team. So sometimes you got to zoom out and rebase. And I think the good platform engineers that I've been seeing lately is they build what they have to, and they rebase when they see that something is ready for production. And when things aren't ready for production, they're usually up there contributing upstream to make sure that it is, and then they re-platform and rebase. And the last thing I'll say here is that the abstractions we have now, all of these infrastructure as code, I like to think about as infrastructure as data, because the infrastructure APIs are much more rigid. You don't need really code every time. And the concept of a container image, we automate until we can abstract. And our abstractions are getting so good that the ability to go from one platform to another is much easier than it's ever been. So I think that's the future of platform engineering. You build it until you don't have to.
I love that. Build it till you don't have to. You started empathetic engineering practice at Google Cloud. One of the things that's interesting is how you actually worked, with the different Google customers, the different Google technologies, but it was all about helping developers connect, right? And really seeing the big picture. What do you see going forward? How does that still kind of run in your veins?
Yeah, look, when I was a junior engineer, I'm like, it's all about the code. You learn everything, every keyword, you rememorize it, you read all the code you can, you write all the code all day, type, 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 type. And you're like, yo, slow down. It's not all about the software. The developer's like, that's what software engineering is. It's literally in the name. I was like, all right, let's just do a test. Get out your laptop, get your IDE ready to go. And I'm like, build it. And they're like, what? I was like, aha. The what is super important. It comes before everything else. So empathetic engineering at Google, we have all these smart Googlers. They work on distributed systems, schedulers. They know all the computer science things. And the very first empathy session that I did at Google, I had Joyce join Google coming from CoreOS. I used to contribute to Kubernetes. And a lot of the engineering team from Google, we were at DockerCon one year. We're just sitting in the audience. And Solomon Hykes walks on stage, and Kubernetes had just came out, and it was rough around the edges, and Docker was known for their wonderful developer experience, right? It was easy to use. And they introduced Swarm V2. And boy, did it have a lot of Kubernetes features in it. And we're just sitting there, it's like, wow, they made that easier to use. Oh, we're gonna lose. That's it. We're all gonna be using Docker Swarm any minute now. And the team was just so distraught, like, oh, we're missing something. We don't know what we have here. We don't know how to close this gap. So we get back to the Google headquarters, and there's an engineering offsite. And I asked all the engineers, was like, look, what do you think the problem with Kubernetes is? And they're like, oh, it's too complex. I was like, complexity is inherent in the job. It has to live somewhere. You can't just say it's too complex. You can't simplify everything away. It has to live somewhere. And so I asked the team, I said, all right, look, I think there's an answer to this question. I don't know if it has anything to do with complexity though. So all I want you to do, and this is all the distinguished engineers, all the people that worked on board, the people who created Kubernetes, we got in one room, and I said, all right, all I want you all to do is install Kubernetes without this little script we had. It was called kubeup.sh. You ran this bash script, it ran for like 6 years, and when it was done, you got a Kubernetes cluster. And I was like, but you can't use that script. You just got to install Kubernetes from the ground up. And you got an hour. And I walked around the room and they were struggling. It was hilarious. I was like, aren't you all Google engineers? Don't y'all know how to build binary trees on a whiteboard? You can't install Kubernetes? And they were struggling so much, and they had to feel it for the first time. And I had each team present. And I was like, how far did you get? I was like, I don't know, man. We were debating what Linux distro to install. We were debating what version of Docker to install. Do we need etcd or not? And I was sitting there like, you know what, that's the problem. A lot of times when it comes to system administrators, we need to just know the blueprint first. And so I said, what should we do? One team decided to build this tool called kubeadmin, and it will help you step through all these decisions in an automated tool. And I thought we needed something more, and I said, I'm gonna build documentation called Kubernetes the hard way. And it allows you to go step by step, all the way down to making TLS certificates, putting binaries in place, setting up a VPC. And all the system administrators, when they saw the guide, they saw all the moving parts, every config file, every TLS connection, every IP address. And when they were done, they were like, oh, I understand it now. And even though it's still complex, a lot more people were more confident about what the system did. And they would find our appreciation for it. And they looked at Docker Swarm, and it's like, oh, it's only solving a fraction of the problem. We're gonna stick with Kubernetes and go forward. And so a lot of engineers at Google started to using this method of empathetic engineering. Take a real world problem, put your hands on it, see how it feels, and then decide what needs to happen. Commit to it, ship it, and then when you launch it, real people who have those kind of problems will see it and it's like, oh, this solves my actual problem, not some new fancy way of doing things. And so empathetic engineering became a deep part of the Google Cloud culture, and I'm really proud of that.
That's awesome. I've got like 9 more questions, but I have 3 minutes. So we talked about one that was interesting. You actually talked at another conference earlier this week, and what was interesting, there's massive comparisons to hardware. You know, you look at Intel and how they're building hardware.
No. That was a question you wanted to ask.
Oh, fine. Then we'll go with the one that I wanted to ask.
You know you wanted to ask. He wanted to ask about Terraform.
All right.
You wanted to ask about Terraform, and it was a good question because I've been in open source for a while, and the interesting thing about HashiCorp is we should give a big shout out to HashiCorp. For a decade, they built some new APIs better than the cloud providers themselves for managing things in the cloud. So maybe we give a big round of applause to HashiCorp.
If we're going to take it HashiCorp, then if we're going to take it with HashiCorp, then we look at OpenTofu, and we've seen a split now. Right? People have changed the way that they've gone from open source to going to their business model. What are your thoughts on that?
Yeah, so Terraform changes their license, right? They decide that, hey, look, maybe we don't want competitors using our logo to integrate in their products and doing things like what was shown earlier today. And so now the community has to make a decision. Now the parts of the community like you all that are directly impacted, you need an alternative. And a lot of us have built products and platforms on top of open things, like Terraform is written in Golang, which is an open source project that they built on top of. So all of us are all building and standing on the shoulders of giants. When you take that away, I think the biggest controversy here is that what was once open, we thought the project was ours. And we found out the hard way that it's not, that a singular entity can make a decision that we may or may not agree with. And so the license gets changed. And so now you have to do something. Now here's the weird thing is I had a project called CompD. When I left Puppet Labs, I wrote a small configuration management tool called CompD, and I was adding all of these backends. So it's a key value store, it reads things from key value store, and it translates it to config, and it pushes it out. So for people that are going like to containers, maybe you don't need Chef, Puppet, and Ansible. And I remember working with the HashiCorp team, I integrated things like Console, but when they released Vault, they had a GitHub issue, and they said, Kelsey, we like CompD to integrate with Vault. And I said, no. I think it's going too far and it's getting out of scope of the project. And the HashiCorp team built a competitor to CompD. They built a thing called Console Template. And I remember it landed on Hacker News, and someone was like, hey, this is a ripoff of CompD from Kelsey. And Mitchell jumped in, Mitchell Hashimoto, one of the founders of HashiCorp. He says, hey, we're big fans of CompD, we were inspired by it, and we wanted to add some features, and so we decided to build a Console Template to do it. And I followed up and said, listen, this is how open source works. I, as a maintainer, I get to make a decision, and if I say no to something, then forking is part of open source. It's right there, and at the top of GitHub, you can click the button. And so what happens with OpenTofu now is there's a split. So we know the software has been split, it's been named OpenTofu, and now we have to decide, will the community split? I think people that want to embed Terraform and that dialect because it became an industry standard, I think you have every right to take that project, hopefully remain compatible with the other side, because the worst thing that can happen is if we get 2 different dialects of HCLs and the cloud providers don't work. So hopefully that stays intact. But I think the community, and we got to remember, HashiCorp, Terraform, and Vault kind of predate the CNCF in many ways. I think a lot of people are now at the point where infrastructure needs to be open, just like our freeways and airports. I don't know if people want to go build on things that the IP and the logo and the community isn't clear going forward. So I think the right thing has happened, but as you know, a fork is only where the start happens. 5 years from now, we'll see if they're able to do all the hard work that HashiCorp was able to do over the last decade. So I'm glad it's there, and now the community has to step up.
I love it. Thank you so much, Kelsey, for joining us today. Really appreciate it. Thanks, sir.